Morning, guys. So today we are doing introduction to geometry, and we're going to cover some terminology and why is this module important to you guys. It is because you are going as designers, you are going to find yourselves having to draw lines and shapes, and this is intended to give you the vocabulary that you will encounter in other subjects and in general as a designer. So the objective is to give you some foundational basics about geometry. So in geometry, the basics that you're going to encounter at the least would be things like a point, which is literally just a dot, and vertical lines. You're going to have to draw vertical lines, which is simply a line going up and down, or horizontal line. One goes going across left to right, and planes as well, which is simply the surface, a flat surface that goes on forever in all directions. So those are the four undefined terms that you're going to encounter in geometry, and you most likely going to apply in your design career. Continuing with the basics of geometry, how do we classify angles? There are four types of angles that form the basics of geometry. There is acute angle, right angle, obtuse angle, and a straight line. So the acute one will be, the typical angle will be less than 90 degrees. And the right angle one will measure 90 degrees. And the obtuse one always measures more than 90 degrees, but less than 180 degrees. And there's a straight line which is always less than 180 degrees. These are the simplest or the basics of um, angles in terms of geometry. Now let's look at the intersection of lines and planes, which again you're going to find yourself having to draw lines and having lines intersect and planes intersect. So perpendicular lines and parallel lines. First, let's look at this one, which is intersecting lines. Intersecting meaning the two lines cross at some point, in this case at point C. So when you talk about parallel lines, this here, this line and that one are parallel to each other. What that means is if you were to extend them, they will never touch, they will never intersect at any point, as opposed to if you drew them like that. These are not parallel lines. So if you measure from point here to that point, it should be the same as measuring from this point to that point, and all throughout the parallel lines they should be the same. Right angle or perpendicular lines are the ones that intersect at right angle, not like an acute angle on that side or obtuse this side. No, they have to intersect at right angle. That explains perpendicular lines. So there are various ways this can be modeled. One of the ways is to look at this lines intersecting, planes intersecting, and in sort of a 3D visualization. So you have two planes here, G and H, intersecting along this line here. Then you have a line, a straight line, B, F. point A. Another line which intersects the previous one at point A. So this is just you visualizing lines intersecting and planes intersecting. Then you have another line, EC, intersecting the plane as well. So you've got two lines that are intersecting at point A, and you've got a line BF from there to there, which are intersecting planes G and H, because the two planes by themselves were intersecting at this area here, and there is a line also that intersects both the planes. And then the point E here, this is where the line EC intersect the plane H, which is that one. So I thought it's a cool way to kind of visualize lines and planes intersecting in a three-dimensional space. This I feel is very important because, you know, when you're making products, there's what you call prototyping, which is making a model before you make the final one in a way. So it's a cool exercise to do. Have pieces of boards or chipboards or foam core, and then interlock them, slot them without using adhesives or any permanent joining, just to visualize whatever three-dimensional product you're making. Just to test your understanding of the basics of geometry, look at this figure here, the box here, and then try and figure out and practice this, seeing that today is Teach Yourself Tuesday, because you're not actually going to get an exercise. It's just for you to have enough vocabulary that you can apply in other subjects. So some understanding about geometry. Where does the plane ABCD intersect the other plane ACEG? Here. And then what plane contains the points C, D, and B? And then bear in mind the definitions of planes and points and lines. What plane contains the points E, F, and C? See what you get with that. So I'm not giving you answers for this. It's for you to practice and just to test your understanding. Then let's move on to another set of vocabulary which is going to help you understand what you're doing as well in other subjects. You will hear a lot of time other lecturers asking you to draw and be accurate and be precise, and just to explain what that means, and then maybe you can apply, like with this understanding, apply it to when you have to be accurate in whatever you are doing. So accuracy simply measures how close the values are to the true value. The true value is a target. So when you talk about accuracy, there has to be a target, an intended true value. So remember that accuracy has to do with a target, and then the measurements, how close are they to the true value. Unlike the precision doesn't have anything to do with a set target. It just measures how close your measurements are to their average. Just to look at them in picture format, we know this is a typical target, and then if you hit anywhere else other than the target as shown here, so when you look at this shows precision without accuracy, because we said accuracy has to do with the target, which should be that one. You're not hitting the target, hence there's no accuracy, but the points are close to each other, showing precision. This one shows both accuracy and precision because you're hitting the target and the points are close to each other. This one shows neither because you're not hitting the target and the dots, the points are far from each other, so they are not precise as well. So what this means is that accuracy has to do with target. For instance, if a brief gives you a set of measurements for a particular product, the given measurements are your target and you have to adhere to them. So you can treat it in that way. Have a target. If you are asked to measure however centimeters, however millimeters, that is your target. When you measure, you have to get that specific number. You have to adhere to that. A different way to look at this is we have what we call standards, and there are certain products which are designed within the boundaries of the national or global standards. Hence, those are your targets and you have to adhere to them. For instance, if you have an A4 or an A2 paper or A3, etc., and then you are measuring those papers, you can't get anything outside the standard measurement of those particular sheets of papers. Those are standards, so you can't be off by even a 0.1. That shows accuracy. Let's apply it to the terminology we just dealt with about angles. So using the right angle, they will always measure, right angles will always measure 90 degrees. If you measure 91, it's not a right angle. So that's your target. You have to be accurate when you're measuring it strictly to 90 degrees. It will always be like that, intersecting at 90 degrees. Not 89, not 89.99. It has to be accurate. Similarly, a straight line will always measure 180 degrees. Nothing more, nothing less. So that is a typical standard, which we can interpret it as a target. This is for you guys to apply it to the briefs that you get and stick to that as your target. Be accurate as possible when you are working through your briefs. Then just to give you, because the importance of geometry has to do with lines, points, and shapes. The typical shapes that you will encounter will be polygons. So the number of sides of a polygon gives the polygon its name. If you have 3 sides, it will be a triangle, 4 quadrilateral, 5 pentagon, and so on and so forth, depending on the number of sides. And then can you guess this one? Or can you name it, not guess rather? This one has 1, 2, 3, 4, 5, 6 sides. That means it's a hexagon, as we just saw. And that one has 1, 2, 3, 4, 5. 5 sides, which means it's a pentagon. And then just to look at a few more, and that is the end of this short lecture on geometry. Hopefully that helps and gives you some familiarity in terms of this terminology that you are likely to work with and encounter or hear in every brief every now and then. Cheers, guys.